So for this example, it says, using a unit circle, determine the coordinates of, and then we have these 5 scenarios here. A says with a radius of 4 units is a central angle of 210 degrees. Now, if we're going to be using a unit circle, we have to remember that we're also going to be using our special right triangles. So I'm going to put in a unit circle here. You should too. Mine is a graphic only because it's easier to demonstrate, but you should go ahead and always draw a unit circle. It kind of gives you clarity and allows you to see what's going on. So I have my unit circle here, and it has a central angle of 210 degrees. So a central angle of 210 degrees, that's probably somewhere right around over here. Now this central angle here, that's going to be 180 degrees, right? That's 180 degrees. And then I add another 30 degrees. So I put in another 30 degrees. And of course that comes out to be my 210 degrees. So actually what I'm going to have here, I go ahead and draw in my special right triangle. I have a 30, 60, 90 special right triangle. And here it is. You can see it here. Now using the pattern of our special right triangle, if this is a unit, a length of 1 unit, then this right here, that's 1/2, but don't forget we're coming down. We're talking about a coordinate. We're in the 3rd quadrant here. That's going to be negative 1/2. And along our x-axis here, that's going to be negative root 3 over 2. So what I like to do is I like to write it like this. I have a radius of 1 unit. Then I'm going to have coordinates of negative root 3 over 2, and another one of negative 1/2. Now again, that's with a radius of 1 unit. If I have a radius of 4 units, I just write it like this. And then all I do is, since I'm multiplying the size of the radius by 4, I also have to multiply the side lengths by 4. So that's what I'm going to do. So this is going to become negative 4 root 3 over 2 and negative 4 over 2. This simplifies to negative 2 root 3. And this simplifies to negative 2. So the coordinates for a point with a radius of 4 units and a central angle of 210 degrees, it's going to have coordinates negative 2 root 3 and negative 2. Now we can check it. Since we multiplied 4 into our special right triangle, we're going to extract it out. So if I type in negative 2 and then the square root of 3, and I'm just going to hit enter. But then since this is a multiple by 4, if I divide by 4, I have negative root 3 over 2, which is this right here. You could do the same for the other coordinate, but it's a good way to be able to check. So we're going to do this for each one of these. That was A. Here's B. We have a central angle of 210 degrees again. So that's back to over here. We already determined that's 180 degrees plus 30 degrees. So that gives us our special right triangle again. This right here is our 30 degrees. So we have our 30, 60, 90 again. This is negative 1/2. This is negative root 3 over 2 because we are looking for coordinates, not just lengths. But that's if the unit measure is 1. So I go ahead and I do 1. Negative root 3 over 2, that's our x coordinate. That's along our x-axis. and negative 1/2. That's our y-coordinate. That's along our y-axis. But we have a radius of 22, so I just go ahead and I put in 22. Negative root 3 over 2 and negative 1/2. Again, since I'm multiplying my radius here or my hypotenuse by 22, the side lengths or the coordinate also has to expand by a factor of 22. So this is then negative 22 root 3 over 2 and negative 22 over 2. And of course that simplifies to negative 11 root 3 and negative 11. So a coordinate with a radius of 22 units and a central angle of 210 degrees will have a coordinate of negative 11 root 3 and negative 11. And again, we can check it since we're multiplying this by 22. And again, we are strictly using our special right triangles to be able to give us these coordinates. So since I know the relationship of those side lengths, if I go ahead and I multiply negative root 3 over 2 by 22, then if I take negative 11 times the square root of 3 and then divide that by 22, I'm right back to my coordinate here. And we'll continue. A radius of 2.2 units and a central angle of 135 degrees. So 135 degrees, that's going to be right up through here. This 135 degrees, that's 90 degrees plus another 45 degrees. So what we have is another special right triangle, except this one is a 45, 45, 90 special right triangle. So we use the pattern of the 45, 45 special right triangle. If this has a unit measure of 1, a radius here of 1, or a hypotenuse of 1, then this here is going to be root 2 over 2. But we're looking for a coordinate, so this is coming back root 2 over 2. So this is going to be negative root 2 over 2. And up along the y-axis, root 2 over 2. So then again, if I have a radius of 1, then I'm going to have negative root 2 over 2 and positive root 2 over 2. But this isn't a radius of 1. It's asking for a radius of 2.2 units. We can type in 2.2, hit enter, and then I have these double arrows here, and that's 11/5. So I'm going to use this as a multiple of 11/5. Negative root 2 over 2 and root 2 over 2. Now, if you don't have this conversion key here, 2.2 is 22 divided by 10. 22, that's 11 times 2. And 10, that's 5 times 2. And these common factors will cancel, and there's your 11/5. So now I'll just multiply the 11/5 to each coordinate here. So this is negative 11 root 2 over 10. 5 times 2 is 10. And 11 root 2 over 10. So the coordinates of a point with a radius of 2.2 units and a central angle of 135 degrees are going to have a coordinates of negative 11 root 2 over 10 and 11 root 2 over 10. And we'll continue. This has a radius of 0.8 units and a central angle of 30 degrees. So here is our 30 degrees right there. Here's our special right triangle. If we have a radius of 1 unit, this here along our x-axis, that's the square root of 3 over 2. And this is 1/2. So I go ahead and I put down 1 as my radius measure. And I put in root 3 over 2 for my x coordinate and 1/2 for my y coordinate. But it has a radius of 0.8 units. 0.8, that conversion, that's 4/5. Or you can think of as 0.8 as 8/10, and that simplifies to 4/5. So I'll go ahead and I'll do 4/5. So this becomes 4 root 3, 5 times 2 over 10, and 4 over 10. 4/10 simplifies to 2 root 3 over 5, and of course 2/5. So the coordinate of a point with a radius of 0.8 units and a central angle of 30 degrees is 2 root 3 over 5 and 2 over 5. We have one more. We have a radius of 16 units and a central angle of 180 degrees, so it's right here. Here's your 180 degrees. So this is what we have, a measure that's right here. 180 degrees, that's a straight angle. It's just a straight line. But this is 1 unit. It's not 1 unit. It's going to be 16 units. So this coordinate right here, that's at -1 and 0. That's where this is right here. But we have a radius of 16. So if I did 1, -1 and 0, but it's now 16, -1 and 0, it actually has a coordinate at -16 and 0. And maybe just looking at it logically, that if we have a radius of 1, thus giving us a coordinate of -1 and 0, then a radius of 16 is going to put us way out off the video here at -16. But it's going to have a coordinate at -16 and 0.